Hello YouTube, this is Supernova Watch 2000 bringing you news on latest supernovas, coronal mass ejections, and all utter destruction of communications on this Earth, which is what a coronal mass ejection can do. Now, this is a picture of a supernova. A supernova is a giant ejection of gas or explosion from a star whenever it reaches the end of its lifetime. Now, this is one of the stars. Now, there are other ones, such as. Give me a second. Now, these are some supernovas. Ignore the picture of the acrobat, I don't understand that picture, but here are some pictures. Now, this is a very strange one. It's a mysterious supernova. This is a supernova from a planet with a view from a planet. This is a galaxy, which is a nearby supernova over here. See that one right over there? That is a big, big supernova. Now, supernovas can expand for years and years and years, and they can get as big as it can grow. Now, this is the Crab Nebula, one of the most famous known supernovas. Okay, now, with a supernova comes a lot of gas. I'm talking about major gas, okay? So, recent supernova explosion. If you search that, you will find discovery of most recent supernova in the galaxy. Now, once you click on this, this is a recent. Now, even though it says 140 years, that's really recent. The last known supernova in our galaxy occurred around 1680. An estimate based on expansion of its remnant, Cassiopeia A. Now, not seen with optical telescopes because it occurred close to the center, embedded in a dense field of gas and dust. Okay? Now, this is big, dude. Okay, so news, nothing really new. Let's see here. Wait, what was that? What was that? Multimedia. Interactive NASA images. Images, here we go. Come on, okay. Now, it's great images, space images. See, now, the astronomy picture of the day, let's look at this. I know this is Supernova Watch, but this is bringing you all things space, if I forgot to tell you that. Now, you see this? Cocoon Nebula Wide Field. Let's see what this says, or shows. This is, September 29th. So, wait, never mind. But, this is, like, taking a while. Here we go. This is, oh, that is pretty. Did you see that right there? This right here. And go down. Let's see. That's big. That's really big. Let's see here. So, now what we want to search is, just to do it easier, let's see here. Coronal mass ejection. Coronal mass ejection. Here we go. This is Wikipedia, but I know this is a massive burst of solar wind, and it's on Wikipedia. But look, right here, it's time lapse. Boom, right there. And there. Oh my goodness, that is big. Oh gosh, that is huge. Now, let's see here. Stereo A. Stereo. Here we go. So now it's yeah. But let's see here. Stereo ahead, stereo behind. Now if you look at this, you can see a lot of spots where there's most likely going to be coronal mass ejections. This comet, very, very stupid, is going to run into the sun. See here, home. Yeah, well, this is home. NASA stereo. Let's look at this and see what it is. I know I'm not really prepared for this. But this is the first video. I mean, can't believe me. I can change directions. Let's see here. Looking for something, cannot find it. Alright, so this is August 1st, 2010. Alright, now let's watch it. Boom. Watch. Boom. Right there. Did you see that? Hold on, let me play it again. Look. Boom. Boom right here. Alright, boom. You see that? That was big. That was really big. But it just shows a picture of the sun because that's a picture that they have that's not so bright as the sun itself because they cannot do that. We're blind as humans, obviously. But yeah. Let's see here. Alright. Look at this. This is eclipsing binary stars. Interesting. Alright, so it says it's a burst of solar wind or other isotope plasma or magnetic fields rising above the solar corona or being released into space. Now, about the 140 years ago supernova, I've covered that on my YouTube channel. Go check it. That's, let's see here. YouTube, okay. Now we just want to click on broadcast yourself. Bear with me here. Okay. So this is the channel here. Now, what's been going on with the sun is like it's been crazy. The sun, as I like to call it, has been having a temper tantrum. Okay, because well, it's been exploding a lot more. Well, not exploding. It's been having more coronal mass ejections. And this is what a coronal mass ejection looks like. Watch and here. Oh, right here. That's where we're going. Okay. See, this is the place here and here where I think this is the most active. Alright, so if you notice here the physical properties right below it. A video series, never mind. Hey, here we go. Alright. Buffering still, keep buffering. Gosh. Never mind, this thing isn't gonna work. But, let's see here. The sun. Coronal mass ejection, coronal loop. See what the coronal loop is. Oh, hey, that is pretty, but weird. Okay, so open flux tube here, and this is the corona as it shows. But here's the photosphere, surface, the chromosphere, the transition region, and these are the loops here and here, and all over where you see the half hula hoops or half tires or whatever you want to call it. This is coronal loops viewed from the Yako, I think, million-degree sun. Let's see here. Any other things that we can? Let's see the supernova. Supernova. Nova. Here we go. Let's see what it says about the supernova. Why in the world does it have convection zone? Do not click on convection zone. Alright, so This is a supernova. Now, don't know if you can see it, but there's a star at the center of this. It's a neutron star now, most likely. But what happens is, well, the star explodes. Obviously, we've already covered that. But just a crab nebula. Let's see here. The type A, 1A. Right here, if you notice, this is a spiral. And this here is Mr. Supernova. Okay. So now, let's see here. The progenitor of type 1A. Now, this is a 2 stars. This one gets bigger. This one spills the gas, causing it to expand. Lighter star in its core spiraled upward. Common envelope is ejected while the separation of the core and the secondary star decreases. Remaining core of the giant collapses and becomes a white dwarf. Aging companions start swelling, spilling gas onto the white dwarf. The white dwarf's mass increases until it reaches critical mass and explodes, causing the companion star to be ejected away or blown away. Let's see here. Let's go back. Now, I had it on full screen just because of the picture. I'm going to have to go back to the normal. Okay, type 1A lacks hydrogen and presents a singly ionized silicon near peak light. 1B, non-ionized helium, no strong silicon absorption near 615 nanometers. Weak or no helium lines, no strong silicon absorption near 615 nanometers. Type 2P, which is a plateau in the light curve. Okay. Type 2L displays a linear decrease in its light curve. Linear in magnitude versus time. Let's see here. Massive evolved star prior to a core collapse. Hydrogen, helium, carbon, don't know. Oxygen, silicon, and Fe, don't know. There's only a few that I don't know. It's the Ne and the Fe. But yeah, that's the onion-like layers of a star. The star explodes in a supernova, comes back in on itself, keeps coming back in and going out, and then finally it's a shell and the little tiny thing right there. X-ray. Well, the Chandra crab. I don't know if that's the crab nebula, but here's the progenitor star. The progenitor star is the star that caused the supernova. Supernova remnant of N63A lies within a clumpy region in the Large Magellanic Cloud. Wolf-Rayet star, WR1234. 124, not 1234. But that would be funny. But, not really much supernovae. Let's see here. The notable ones. Yeah, Crab Nebula is the very first one. Hypernova. The hypernovas are the bigger the bigger supernovas. They are the biggest of the supernovae. It's a incredibly large star. Let's take a star for instance. It's not exploded yet, but VY Canis Majoris, extremely large, the largest star in mass. Say if that was to explode, I don't know if it'd be visible from Earth or not, but it'd be big. It'd be really, really big. It can cause some of the biggest black holes. Yeah, this is all for now, but soon enough we will have more info on these supernovas. Supernova picture right here, awesome.